Here we are. We're talking math. So, let's take a look at this problem. Show that 3 to the 27th plus 2 to the 27th is divisible by 35. I, like many of you, was a bit thrown off when I read this problem. And if you don't have the tools to solve this, it's a mess. I mean, it's beyond a mess, right? We're not going to do 3 to the 27th or 2 to the 27th and then divide by 35. It doesn't really make any sense. So we must use some tool to simplify this for us. And I've written that up here. So we have the sum of odd powers, and behind my head you can see that we do have 3 to the 27th, which is an odd power, and 2 to the 27th, which is an odd power, which does make me think that this is a good thing to use, because we can do some sort of factoring. Right? I'll give you the example of a to the 1 plus b to the 1. That factors pretty easily. But as we go further, we find that we can continue pulling out that a plus b. We have a plus b times a squared minus ab plus b squared. And the pattern follows that we can take a plus b out and leave a to and let me back up and say that 2n plus 1 is used to represent an odd number. Because if we multiply any number by 2, it'll be even. And 3 times 2 is 6, 4 times 2 is 8, whatever. If we add 1 to an even number, it will always be odd, because it's the number after. So here we have a to an odd power plus b to the same odd power. That's sort of crucial here. So if we have that situation, we can factor out a plus b, and then we'd be multiplying by a to the number smaller than whatever, 1 smaller than whatever our odd number is. So a to the, if this was 9, we'd say a to the 8th minus a to the 7th times b plus a to the 6th times b squared minus a to the 5th b cubed. We just keep switching positive, negative, and we eventually get to plus b to the, in the example, 8 or b to the 2n. So I think we can use this in order to solve our problem. Let's see if I can maybe bring this up a little bit closer. So we have something to work with here. Okay. So we have 3 to the 27th plus 2 to the 27th divisible by 35. Now I think at first glance, like just using this straight away, we would factor out 3 plus 2. So we'd have 3 plus 2 times 3 to the 26th minus 3 to the 25th, 2 plus, and so on and so forth, right? Up to 2 to the 26th. Yeah, if the question was show that it's divisible by 5, that would work. We'd be done. We would show that we factored out a 5. But in this case, we're trying to divide it by 35, not by 5. So we can be a little bit more strategic. We could say, well, 27 is odd, but also there are factors of 27 that are odd. So let's say this, instead of 3 to the 27th, was 3 to the 3rd, to, what am I thinking? To the 9th. Maybe we could try that. We could also try, that was, we would do the same thing with 2. So 2 to the 3rd to the 9th. Because when we raise an exponent to an exponent, we multiply them. So 3 to the 3rd to the 9th would be 3 to the 3 times 9, which is 27. So if we choose to see it this way, we're still raising 3 to the third to an odd power and 2 to the third to an odd power. And that was a bit of a guess. We could have tried it the other way around. We could say 3 to the ninth plus 2 to the ninth, both of those to the third, and factor it that way. But what I was thinking is we're going to run into another problem there because those numbers are quite big. But let's do it. Let's just say we made the mistake and we wanted to factor this as it's a big eraser. Oh my gosh. Okay. So let's say we wanted to do 3 to the ninth to the third. Okay, great. 2 to the ninth to the third. Okay, so we've just taken out a 3. And this would be equal to 3 to the ninth plus 2 to the ninth times this. What do we have? We would have 3 to the ninth squared. I don't even want to write this, to be honest with you. I don't think we don't have to. I don't want to write it. It would be minus. It would be 3. Well, that's fine. 3 to the ninth, 2 to the ninth plus 2 to the ninth squared. Great. Okay. We're not going to be able to factor this anymore. We could factor 3 to the ninth plus 2 to the ninth in the same way that we just did this. So we look at it here and say 3 to the ninth plus 2 to the ninth is equal to, well, we want to go back and do it the same way we did it. We want to say 3 to the third plus 2 to the third. And the reason I had to stop myself there is because if we just said 3 to the ninth, 2 to the ninth, then we would get the same result that we did originally. We would get 3 plus 2 times, a whole mess. We'd only be able to say, oh, it is, in fact, divisible by 5. We already know that. We don't need to do anything more with that. Great, so 3 to the third plus 2 to the third. And then we're still multiplying by this whole thing. It doesn't matter, though. This is, so big. We're not going to get 35 out of that. We're not going to do 3 to the ninth to the second. But here, we can continue with 3 to the third squared, parentheses, minus 3 to the third, 2 to the third, plus 2 to the third squared. Yeah. I think at this point we could go and start to check and see, okay, do we have our factor of 35? And we're still multiplying by this whole box. Doesn't matter. We're not messing with it. So we could say 3 to the third is 27. 2 to the third is 8. Great. 27 plus 8 is 35. We don't need to continue. We could get that 5 again, and we could get another number in parentheses here, which would probably be 7. But regardless, we see that 27 plus 8 is 35. This is a factor, one of many factors of 3 to the 27 plus 2 to the 27. Okay, let's do that again, but a little quicker. Okay, 3 to the 50th plus 8 to the 50th is divisible by 73. So this is a bit different. This is not odd, but we can pretend like it's odd. And when I'm thinking about things that multiply to be to 50 that include an odd number, right? We could do, we have the option of doing 3 squared to the 25th plus 8 squared to the 25th, or we could do 3 to the 5th to the 10th. Oh, sorry, that's backwards. 3 to the 10th to the 5th plus 8 to the 10th to the 5th. Okay. Now, I think, like, if you get a little bit more experience with these problems, you can kind of see what you want to do. We could pick one of these that's going to be maybe a little bit faster. Because we know that this is going to factor out, like the first thing that we're going to get is 3 to the 10th plus 8 to the 10th. And then the mess. Who's called the mess? And here we would have 3 squared plus 8 squared times the mess. Now, if we were to, we would have to continue with this second one. We would have to say, oh, okay, well, 10, we're not going to do 3 to the 10th, we're not going to do 8 to the 10th. It's certainly not 73 when we add them. So what multiplies to 10? That includes an odd number, 2 and 5. So we would end up from here having to go and do 3 squared, like to the 5th plus 8 squared to the 5th, and factor that. And we end up getting here also. We end up getting 3 squared plus 8 squared times the mess. 3 squared plus 8 squared times, well, it'd be a new mess, but it's still a mess. And, I mean, that's about all we can do. We could calculate this if we needed to, but fortunately, 3 squared, 9, 8 squared, 64. 9 plus 64 is my pen's slowing down on me a little, is 73. So this is divisible by 73. We continue, same thing. Now, we could go through again and say the factors of 30 that include an odd number. We have 2 squared to the 15th, or we have 7 squared to the 15th, or we can also try 2, what else works? 2 to the 6th, 2 to the 6th to the 5th, plus 7 to the 6th to the 5th. And once again, go about factoring. We'd have 2 to the 6th plus 7 to the 6th times something. 2 to the 6th, yes, we can do, and it's not much bigger than 53, but it's bigger than 53. 7 to the 6th is definitely bigger than 53. So we'd need to continue, and once again, we'd be left with a 2 squared to the 3rd plus 7 squared to the 3rd. So we could have just picked 15 and 2 as our 2 factors. It's usually the smallest. They were the largest power on the outside and the smallest on the inside. So 2 squared plus 7 squared times a mess. So 4 plus 49 times something. So 53 times something is 2 to the 30th plus 7 to the 30th. So that means that this huge number is in fact divisible by 53. All right, I hope you learned something.